Good day everyone. It's Miss Labasan here. Okay, so before we begin our class, we'll have first a solemn of silence for prayer. So Miss Labasan, kindly lead. Amen. So good morning everyone. Okay, how are you all? Good. I hope you're all fine in your respective houses and stay safe. So you are all 35 in the class and you are 35 in the meeting. So perfect attendance. Very good. Okay, so are you all excited for our lesson for today? Okay, that's it. Good. So before we proceed to our next topic, who can recall our topic last week? Okay. Yes, Miss Ortega. Yes, we tackled about divisibility. So, any clarifications or questions about divisibility and the rules? Okay, none so far. So, we will proceed to our today's topic, which is the mathematical induction. But let me first read the objectives. So at the end of the lesson, the students should be able to first define mathematical induction, second, illustrate the process of mathematical induction, and lastly, prove a statement using mathematical induction. So class, do you have any idea about mathematical induction? Anybody? Yes, Mr. Aljun Kim, you're raising your hand. Yes, proving statements. Another. None? Okay, so what really is a mathematical induction? So mathematical induction is a method to prove that a given statement is true for all natural numbers. It is an important and fundamental tool used when doing proofs. So to understand the basic principle of mathematical induction, suppose a set of domino tiles are placed as shown. When the first tile is pushed in the indicated direction, all tiles will fall. So, for example, the first statement is true, so the second statement that follows should also be true, as well as the third, the fourth, the fifth, and so on. So, it gives a domino effect to prove that all statements are true. Proofs has two steps, the basis step and the inductive step. So the basis step shows the first term is true. So let us take the mathematical result in terms of n. So in this step, we let n I will let n equals to 1, then making the left hand side equals to the right hand side. So, in the inductive step, prove that if any one statement is true for k, then the next one, k plus 1, is also true. So, we will have an example. So, we will prove that 1 plus 4 plus 7 plus all the way plus 3n minus 2 is equals to n times 3n minus 1 over 2. So we will solve this, prove this equation by using mathematical induction. So the first step is to let n is equals to 1. So since the first term is 1, so this is the left hand side. So the right hand side is to substitute this n to 1. So we have 1 times 3, substitute 1 n to 1, so 1 minus 1 over 2. So we have 1 is equals to 3 times 1 is equals to 3 minus 1, 2. 2 times 1 is equals to 2. 2 over 2, which is 1. 2 over 2 is equals to 1. So it is true. The first statement is true. So we let another n is equals to 2. So since it is the second statement, so we have the first and second term. So 1 plus 4 for the left hand and substitute n by 2. So 2 times 3 times 2 minus 1 over 2. So 1 plus 4 is equals to 5. And 2, 3 times 2, 6 minus 1 equals to 5 over 2. So we have 5 equals to 2. 5 times 2 is equals to 10. Divided by 2 is equals to 5. So the second statement is true. So for the second step, the inductive step, which is the prove that n is equals to k, and the next one, n is equals to k plus 1, is true. So we will assume that n is equals to k is true. So we will substitute this n to k. So we have 1 plus 4 plus 7 plus all the way to plus 3. So we will substitute n to k. So 3k minus 2 equals to k. 3k minus 1 over 2. Then we will prove that n equals to k plus 1 is also true. So we have 1 plus 4 plus 7 plus all the way to plus. So we'll copy this 3k minus 2 plus, since we will prove that k plus 1, n is equals to k plus 1, so we will substitute this k to k plus 1. So we have 3 times k plus 1 minus 2 is equals to, substitute k to k plus 1, k plus 1 times 3k plus 1 minus 1 over 2. So we will prove this. So this time, to prove that n is equals to k plus 1 is also true, so we will replace this to this, since it is equals to k times 3k minus 1 times 2. So we will copy k times 3k minus 1 over 2 plus this 3 3 k plus 1 minus 2 is equals to, copy, k plus 1 times 3 k plus 1 minus 1 over 2. So, we will prove this equation. So, simplify. K, copy 3k minus 1 over 2 plus 3 k so 3 times k, so 3, we have 3k, so 3 times 1, 3, minus 2 is equals to 1, so we have plus 1 equals to k plus 1, 3 times k equals, we have 3k, then 3 times 1 equals to 3, minus 1 plus is equals to 2, so we have plus 2, so all over 2. So we will add this. So to get this sum, so we will get the denominator. So we have k, 3k minus 1 over 2 plus, we have the denominator of 2, so 2 times 3k plus 1, 2. So, have k plus 1, 3k plus 2 over 2. So, we will multiply both sides by 2. So, cancel. So we have the remaining k times 3k minus 1 plus 2 times 3k plus 1 equals to k plus 1 times 3k plus 2. So we will simplify k times 3k. We have 3k squared minus k times negative 1. We have negative k plus 2 times 3. We have 2 times 3k. We have 6k plus 2 times 1. We have 2 equals to 3k FOIL method. K times 3k, we have 3k squared plus k times 2, we have 2k plus 1 times 3k, we have 3k plus 2. 1 times 2 is 2. So, combine like terms. So, 3k squared, 6k plus negative k. We have positive 5k, copy 2. So, we have the left hand side is equals to 3k squared plus 5k plus 2 is equals to 3k squared plus 2k plus 3k, we have 5k plus 2. So, therefore, left hand side is equals to right hand side. So, this equation is applicable to all terms. Okay, so let's have another example. So, 2 plus 6 plus 10 plus all the way to 4n minus 2 is equals to 2n squared. So, we will prove that it is true for all natural numbers. So, we will prove this equation by using mathematical induction. So, as usual, the first step is to let n is equals to 1. Since we have the first term 2, so we have 2 equals to substitute n is equal n to 1. We have 2 times 1 squared. So we have 2. So 1 squared is equals to 1. So we have, so first statement is true. So we let another n equals to 2. So 2 plus 6 and substitute n to 2. We have 2 times 2 squared. So 2 plus 6, we have 8. And 2 times 2 squared, 2 times 2, we have 4. So 8 is equals to 2 times 4 is 8. So understatement is true. So now we will assume that n is equals to k. So we have 2 plus 6 plus 10 plus all the way to plus 4. Since we let n is equals to k, so we will substitute this n. K minus 2 equals to 2k squared. So now we will prove that n is also true by n is equals to k plus 1. So we have 2 plus 6 plus 10 plus all the way to 4k minus 2. Since we let n is equals to k plus 1, so we add 4. Substitute k by k plus 1. K plus 1 minus 2 is equals to 2. Substitute k by k plus 1. K plus 1 squared. So now we will replace this to 2k squared. So we have 2k squared plus 4k plus 1 minus 2 is equals to 2k plus 1 squared. So we'll now solve. So 2k squared plus 4 times k, we have 4k, 4 times 1, we have 4 minus 2 equals to 2k plus 1. Since we have k plus 1 squared, so times k plus 1. Then we will combine, add, so 2k squared plus 4k plus 4 minus 2, have 2 equals to 2k plus 1 times k plus 1. So we have squared plus 4k plus 2 equals to 2 times k we have k squared plus k times 1 we have k plus 1 times k we have k plus 1 times 1 we have 1. So combine. So 2 times k squared plus 2k plus 1. Then we have 2 times k squared, 2k squared plus 2 times 2k, we have 4k plus 2 times 1, we have 2. So we have 2k squared plus 4k plus 2. So left hand side is equals to so this statement is true. So class, did you understand or learn what we discussed today about mathematical induction? Is easy, right? Yeah, super easy. You're all smart and intelligent, so it's just easy for you. So, do you have any questions, clarifications? Don't be shy to ask questions. Okay. Since you have none questions and clarifications, so we will have an activity. So, you will answer these equations and prove it using mathematical induction. So, these 5 equations. I will give you 30 minutes and just PM me for your answer. Since it is already 8:30 in the morning, so you will pass it before 9. Okay? So just PM me for your answer. And for your assignment, I'll just post it in your Google Classroom. Yes, to be passed next week. So that's it, class. You can now leave the meeting. But don't forget to pass your activity before 9 a.m. Okay? So goodbye and stay safe, everyone.